Okay, so today I'm going to discuss about recursive functions in Python. Now, what is this recursive function? It is also sometimes called recursion in Python. It is a generalized concept. That means there are several languages, computer languages, in which this recursion is supported. So Python is one such language where recursion is supported. What actually happens is, a recursion is a method by which we call a function within itself, by itself. Now, you can imagine this to be a bit peculiar. How can a function call itself within itself? Although it sounds a bit peculiar, but this is what actually happens in recursion. I'll give you a small example before we get into the details of this type of function. Let the name of the function be fun. And let me print a message. Say print hello. And then let me call the function once again. Let's see what is going to happen. From here, the main program begins. And let me give the name of the function for invoking or calling the function. Now let's see what is going to happen over here. When the program execution begins, it begins from here. I'm making a call to the fun function. So the entire control gets transferred over here. Whatever is the content over there inside that function, it gets executed. We have seen this earlier when we discussed about functions. So here it's going to definitely print hello. And before this function ends, once again I'm making a call to this function called fun. So once again the control comes over here. It displays the message hello. And even this time it doesn't end. Again, there is a call to the function named fun, and again it displays the message hello. And this process, you can understand, it continues. Although it looks like that it's going to continue forever, that is an infinite number of times, eventually you are going to get an error message that this particular function had crossed the recursive depth. Now what does it mean is, you see, every time you call a function, it occupies a certain amount of memory. And here you see, before the function ends, once again I'm making a call to that function named fun. So what actually happens is, before the function ends, there is one more call to that function. So the previous function do not end over there. While not ending, once again I make a call to this function. So it is going to occupy a different memory location. So you can imagine it's something like this. So fun is there. This is a part of the memory where the fun function resides. Once again, I make a call to this fun function. So once again, you can imagine the fun function resides in the memory. And before this function ends, once again, I make a call to the fun function. So this might look like that it's going to continue infinitely, but actually in computer, the memory is always limited. So you will naturally come to a situation where the memory is going to get filled up. That is why Python, puts a check over there that the number of recursive depths should be controlled. Now, this is what I want to tell you, that when you go for recursion or use recursive function, you need to put a condition so that you are going to not further continue calling this function. Like in this case, you are infinitely calling this function, which is going to create a havoc to the memory requirement. So what we are going to do is, we are going to make a controlled process of calling this recursive function so that it does a particular job. Now what I'm going to do is, I'm going to give you an example where I'm going to find the sum of first n natural numbers, where n may be any value which will be given from the main function. What I'm going to do is, I'm going to use a recursive function that is going to find the sum of first n natural numbers. Now let's see how do we do that. Now let's see how this particular function works. This function, as mentioned earlier, it's going to find the sum of first n natural numbers. So here you see, what I'm doing is, I'm making a call to the function sum and I'm passing 5 to it. 5 indicates that I'm going to find the sum of first 5 natural numbers. That is, I want to find the sum of 1 plus 2 plus 3 plus 4 plus 5. So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. Now we are going to check whether it really gives us this 15 as a result or not inside the variable p. Now here you see what I did is I made a call to the function named sum and I'm passing 5 to it. So this is the value of n. Now it's written out here, if n equal to 1, obviously n is not 1, so it directly jumps to the else part, and in the else part, what is written out here? Return n plus sum n minus 1. So it's going to return n, in our case n is 5, plus sum n minus 1, that is 5 minus 1, that happens to be 4. Now you see, there is a peculiarity over here. Although we have seen earlier that return is used to return a value and exit from the function, but here, since we have another call to the function named sum, the return will not be able to have a value so that it is able to return a value from that function to the main part of the program. So what happens is, until and unless it doesn't get a value from here, this return is not going to work. So it remains hanging in the memory. So here you see this variable n will get the value 4. Now please remember, every time you make a call to the recursive function, it occupies a separate memory location. Therefore, this n has nothing to do with this n. This n still resides in the memory having the value 5, and this n is going to have the value 4 and it's going to reside in the memory. Now once again, let's see what is happening over here. If n is equal to 1, once again it is not 1, it's 4. So it directly comes to the else part, and in the else part what is written? Return n plus sum n minus 1. So return 4, because the value of n is 4 inside this sum 4 function, plus sum n minus 1, that is 3. Now once again, here the value of n is 3, which has nothing to do with the previous two values of n. And here, once again, it's going to return 3 plus sum 2. And this is the new value of n, which has nothing to do with the previous values of n. It is occupying a separate memory location. This again, in the meanwhile, is going to return 2 plus sum 1. And now you see a unique thing happens. When the value of n is 1, it's going to return 1, indicating that here for the first time I am controlling the way the recursive function is being called. When the value of n reaches 1, there is a subtraction of value of n every time I call the function sum by 1. So when the value of n reaches 1, there is no further call. Instead, I am returning the value 1 for the first time. So let's see what is going to happen over here. So when it comes over here, it's going to return 1. Now we know that the return statement is going to return a value to the place where it was called. Now you see, this 1 will get to the place where the function sum was called. So where was the function sum called? It was called over here. So the value 1 will come out here. So this 2 plus 1, that is 3, will be returned because this was hanging in the memory. Now it has a complete value 2 plus 1, that is 3. So this 2 plus 1 is going to get returned over here because this function had this statement return. So 2 plus 1, that is 3. I'm writing this explicitly for you to understand. It's going to get returned. Now this return happened because of the sum 3 function. So this 3 plus 2 plus 1 is going to get returned over here. Obviously it is 6. Now this return 4 plus 3 plus 2 plus 1, that happens to be 10, gets returned over here because this return statement is the outcome of sum 4 function. So this entire thing gets replaced by 4 plus 3 plus 2 plus 1. And this time 5 plus 4 plus 3 plus 2 plus 1, that happens to be 15, gets returned. Where does it get returned? To the place where it was called. Where was this called? The sum5 function had called this, due to which this return statement had occurred. So here this entire thing will get replaced with 5 plus 4 plus 3 plus 2 plus 1, which happens to be 15. So the value of P is 15. Print P, it's going to show you the output as 15. This particular statement was the primary cause of not infinitely calling the recursive function. So we call it the test case, or the case in which, or the situation in which we will not further call the function recursively. We are going to make a stop over there and we are going to backtrack the entire event until we get the sum. Now what I'm going to do is, I'm going to show you another method in which I'm going to find the sum of first 5 natural numbers, exactly this same program, but using a slightly different approach. Now what I'm going to do is, I'm going to show you the same program once again, but with a slightly different approach. What I'm going to do is, this is almost like the for loop which we use for finding the sum of first 5 natural numbers, where we store the sum inside a variable, say s. It need not be a for loop, it may be a while loop also. What I mean is, any kind of iterative statement will be using a variable, say s, where we are going to find the sum of the numbers, generated numbers. So I'm going to use exactly that same approach. Now you can see this. So this particular program which we are going to do will be having a slightly different approach for the same program, that is finding the sum of first n natural numbers. Here I have taken two parameters, n and s is given a default argument which happens to be 0. So this has an advantage that when I call the sum function, I do not need to pass the value of s, but subsequent recursive calling to this function, I am going to pass the value of s. Now let's see what is going to happen in this program. So here we have p equal to sum 5. So p equal to sum 5, and during this call the value of n is 5, and s, since I did not pass any value, it remains to be 0. That is the default argument. Here what have I written? If n is 0, no question of n being 0, the value of n is 5, so it directly jump to the else part. S equal to s plus n, so s equal to s was 0 plus n, that happens to be 5. So this happens to be 5, and before ending the program, once again I make a call to the same function. So it's going to return sum, that is the same function once again. Recursively I am calling n minus 1, n was 5, so 5 minus 1, that is 4, and this time I am passing the value of s, which happens to be 5. So this is my n and this is my s. Now this n and s obviously has nothing to do with this n and s, both are occupying separate memory location. This is the primary objective of using recursion, that is, every time you make a call to the function, it's going to occupy separate memory location, with every variable occurring separate memory location. So of course there are performance issues, no doubt regarding it. I'll come across that later. Now let's carry on. Once again n is not 0, so once again out here s equal to s, this time the value of s is 5 plus n, that is 4, which happens to be 9. And once again return sum n minus 1, here n was 4, so 4 minus 1, that is 3, and s, which happens to be 9. Now once again it directly jumps to the else part. S equal to s, s was 9 plus n, this is n and this is s, remember, which happens to be 12. So once again return sum n minus 1, that is 2 comma sum, this time it's 12. So here s equal to s, s was 12 plus n 2, which happens to be 14, and this was my n and this was my s. So once again return sum 1 comma 14. Now once again it's going to jump to the else part, and in the else part s equal to s, s was 14 plus n, this is my n and this is s, which happens to be 15. And after that return sum n minus 1, which happens to be 0, and s is 15. Now this part is very important. This is my n and this is s. Now look at this test condition. When the value of n is 0, return s. So here the value of n is 0, so it's going to return s. And here the value of s is 15, so it's going to return 15. Now where it is going to return 15? To the place where it was called. Where was it called? It was called out here. So this 15 gets returned over here. Now you see, return 15. The previous return 15 is hanging in the memory. So this return 15 is going to return the value 15. Where? To the place where it was called. Where was it called? It was called here. So it comes over here. So return 15. Once again it comes over here. And this return 15 will come over here. And this return 15 will come over here. And this return 15 ultimately will be coming over here. So the value of p will be 15. So print p. Once again it's going to display 15. So you see this is a solution to the same program but using a slightly different approach. This is perhaps more easier to understand because it's almost like the iterative structures which we use generally when we do not use recursion for finding the sum. Now what I'm going to do is I'm going to show you a recursive function where I'm going to find the sum of the digits of a number. So this particular program is going to find the sum of the digits in an integer, and I'm going to use the approach which I had used in the second program where I found the sum of first n natural numbers. Now let's begin what I've written over here. P equal to sum, what is written? 563. So that's the integer whose sum of the digits I require to find. This is the value of n, and since the value of s is not passed, it's going to take the default argument which happens to be 0. Now if n is 0, no way, the value of n is 563, so it directly jumps to the else part, and in the else part d equal to n modulus 10. So it's going to extract the last digit of n, which happens to be 3. S equal to s plus d. So s was 0 plus d, that is 3, which happens to be 3. Now return sum. So it's going to return, eventually once again I'm making a recursive call to this function, sum n integer division 10, that is 56 comma s, which happens to be 3. So here the value of n is 56 and here s is 3. And remember, this n has nothing to do with this n. All are occupying, all call to the function will have their variables occupying separate memory location. So here once again n is not 0, it directly jumps to the else part, and in the else part let's see what is happening. D equal to n modulus 10, so 56 modulus 10 happens to be 6, and s equal to s plus d, so s was 3 plus d plus 6, which happens to be 9. Now once again return sum, calling back the function sum n integer division 10, that is 5 comma s 9. So here once again, since the value of n is not 0, it directly jumps to the else part, and in the else part d equal to n modulus 10. So 5 modulus 10 is 5 obviously, and s equal to s plus d, s is equal to s. Here the value of n is this and s is this, so s was 9 plus d 5, which happens to be 14. And then once again return sum n integer division 10, that is 5 integer division 10 is 0, and s, which happens to be 14. Now look at this. If the value of n is 0, for the first time I have stopped making a call to this function once again. So return s. So it's going to return, this was my n and this was s. So it's going to return s, which happens to be 14 when the value of n is 0. So where will this 14 get returned? To the place where it was called. Where was it called? It was called out here. So 14 comes over here. Now this 14 will get returned over here. And eventually return 14 is going to get returned out here. So the value of p will be 14, and print p is definitely going to show you 14, which is the sum of the digits in 563. That is 3 plus 6, 9, and 9 plus 5 is 14. This is what is happening. Now in the next program, what I'm going to do is I'm going to find the HCF between two numbers, and I'm going to use the very famous method of Euclid for finding the HCF between two numbers using recursion, obviously. Now, let's try to understand the solution for finding the HCF between two numbers. Suppose we have two numbers 6 and 4. How do we find the HCF? So what we do is we start dividing the larger number by the smaller number. So 4 ones are 4. The remainder happens to be 2. So since the remainder is 2, we carry on dividing. So the previous denominator becomes the numerator. So 2 2s are 4. The remainder happens to be 0. So since we got the remainder as 0, the last denominator or the divisor happens to be the HCF. So the HCF of 6 and 4 is 2. So what we are going to do is, we are going to take two numbers whose HCF is to be found. Say the first one is the numerator, the second one is the denominator. First, what we do is, we find the remainder. And if the remainder happens to be 0, so we got the HCF, no doubt regarding it. But if it isn't 0, so what we do is, we get the remainder, and the remainder becomes the divisor, and the previous divisor becomes the numerator of that particular fraction. So this is the approach which we are going to apply over here. So let's take this. Let the name of the function be HCF. And let me take two variables n and d indicating numerator and denominator, easier to reference. Now what we are going to do is, we are going to check whether n is divisible by d or not. If it is divisible by d, obviously d is the HCF. So that is the test case. If n modulus d equals to 0, return d, because that's the HCF. Otherwise, what we are going to do is, first find the remainder, that is this. So this is my n, this is my d. I'm going to find the remainder first. So remainder happens to be n modulus d. So we get the remainder. And since it is not divisible, in this case it was divisible, and since it is not divisible, so what we do is, the previous denominator becomes the new numerator, and the remainder becomes the new denominator. So n equals to d, and d equals to r. And then we carry on with the process of recursion. So return HCF n comma d. Now let me write the main, and then we are going to go for the analysis or dry run of the program. P equal to HCF 6 comma 4. Now print P. So when we start analyzing it, P equal to HCF 6 comma 4. It doesn't matter which number is greater or smaller, because it's still going to work. This is my numerator, this is my denominator. If n modulus d equal to 0, that means 6 modulus 4, if it is equal to 0, now it isn't 0. So what happens? It directly jumps to the else part. And in the else part, r equal to n modulus d. So r equal to 6 modulus 4, which happens to be 2. This is what we see over here. N equal to d. N equal to d. And what was d? 4. And d equal to r. D equal to r, and r was 2. And once again, I make a call, return HCF n comma d. So n is 4 and d is 2. So here the value of n is 4 and the value of d is 2. Now what do we find? If n modulus d equal to 0, obviously 4 modulus 2 is equal to 0. Since it is equal to 0, that means if it is divisible, so that is the common factor, highest common factor, return d. So it's going to return d, which happens to be 2. So where will this 2 get returned? To the place where it was called. Where was it called? It was called here. So the value of p will be 2. So print p, obviously it's going to print 2, which is the HCF of 6 and 4. See how easy it is to use recursion, actually. Now, remember, if you have a performance issue, then we are going to go for iteration. We are going to use the iterative structures, that is for and while. But if you do not have performance issues, if you want the code to look simplified, then we can go for recursion. Please remember, with recursion, the entire process of execution becomes slow. So if you have performance issues in your head, then please do not go for recursion. You can go for iteration. Remember, any program which you do using recursion can be done using iterative structures. However, the program may become too big. Sometimes it is very big to be handled properly. So that is why we have this recursion to make our life easier. That is for programmers who wants to do program very easily and a neat work. So if you want a neat program where we have the same process being repeated again and again, then we can go for recursion. But if you have performance issues, then do not go for recursion because it's going to be slower compared to iterative structures.
Okay, so what we are going to do today is learning how to create a module. And remember module which we had learned, which you have already learned in class 11. What was a module? Module is, an extension of Python where you have few pre-built functions which are made by different organizations or users and which you can import in your program to perform different jobs. For example, remember you had imported math module, you had imported statistics module, you had imported the random module, and so many different functions associated with it, you were able to use it. And remember, whenever we use a function of a module, we use the dot operator uh, whenever commonly that is used. So whenever you'll be using a module, you'll be using the dot operator to access the individual member of the module. So same thing what we are going to do it here today. What we are going to do out here is we are going to create a user-defined module. As user-defined module will allow you to create your own module and allow it to be shared among other users or by yourself only. So I'm going to illustrate that. I'm going to give you a demonstration where we are going to create a module and then share it using another program. That is what we are going to do. Now here what you are seeing is the shell window, and here what you have is a text editor of the Python ideally. And here also we have two text editors. The reason behind opening two text editors this time is inside one I'm going to create the module, and inside another I'm going to call that particular module to execute a particular content of that module. So let's start with it. So what am I going to do is I'm going to first print a statement, say print hello. So this is what I'm going to do inside my module, just display a simple message. So this is what I did. Okay, let me run this particular program, run module. Okay, and then okay, I need to give the name of the file. Let me give the name of the file, say my module. That is the name of the file which I have given. Click on save. Okay, so you can see over there my module.py is the name of the module, and when executed you have seen that it's giving me the message hello. Now what I'm going to do is I'm going to import this particular module, that is this particular file, inside another program. So I'm going to write in this particular editor. So how do I write import? It's pretty simple in Python, you see. Import, and what I'm going to do, I'm going to write my module, and here I do nothing. Say I'm going to print the message outside module, say since we are outside this module, outside module. So I can give this message, and here I'm going to run it. But before that I need to save it, obviously. So let me run it, and then it's asking me to save. Okay, let me give the name demo, and this time demo 5. I'm going to give the name demo 5 and click on the save button. And here you see what is the output. You got hello and you got outside module. Now what basically happened was when you use the import my module, it executed whatever is the content of my module, and then it displayed the message out here outside module. Now suppose, say for example, the benefit of this is, if I have a function out here, when I have a function, the function, what we do with function, we can simply define a function out here, and only when I call it, it will get executed. So until and unless I do not call, it will not get executed. So let me put this contain, that is hello, inside a function named greet. It's a greeting message, great, and out there I'm going to keep the content that is hello. Okay, let me save this. And here, once again, I'm going to, without making any changes, I'm going to run this program now. Let's see what is output. Okay, and here you see this particular function greet did not get executed because I never asked it to be executed. So from here, what you learn that only when you write the main content of the program, that gets executed whenever you import a module. If you have function, until and unless you do not call the function, it will not get executed. So here what we are going to do is we are going to call this particular function called greet from my module. So how do I write? I can write my module, that is what you have already learned in class 11, name of the module dot greet. This is what we are going to do. Okay, now let me execute it, and you can see that particular function gets executed. So you can see the hello, which was the content of the greet function, gets executed along with the message which is out here. Now say for example, this particular program, that is my module program, also has the main part, and here I'm going to display the message, say inside module. Suppose, say for example, this is the main. Say I'm following the convention of writing main over here with a comment, and here what I'm going to do is I'm going to write print inside module. And now what we are going to do is we are going to run the my module program, and you can see it is showing me inside module. And why isn't it showing me greet, the message inside the greet? That is because I never invoked the greet function. So fine, that is what I wanted. Now here what I'm going to do is I'm not going to make any changes out here where I'm importing this file, and I'm simply going to execute it. Let's try. Okay, so here what do you see? You see first the message inside module. Now this is quite weird because you never wanted the main part of my module to get executed. You simply wanted the greet function to get executed. Now this became a problem, that if there is a main part inside the module which you are executing, it gets executed. But Python has made life easier for programmers. There is a variable, internal variable we call it. There is an internal variable called name that is used to control whether the main part of the module will get executed or not. Now let's see how to do that. Okay, so here inside this my module, I'm going to put an if statement. If underscore underscore, this is a predefined variable inside Python. This basically stores the program which the name of the program which this particular program is being executed. So here if it is equal to main, that means if the same program is getting executed, that is I'm going to execute this program itself. If I'm going to execute this program itself, then it's going to display inside module. Otherwise it's not going to display. Now let's see, let me run this particular program. Okay, and there you can see inside module, indicating that this the same program which contains the module, that means the module itself, I'm executing it, and here it is checking whether I'm executing the same program or not. Now when I'm going to execute the program which is importing this particular module, this time you'll find that the main part will not get executed because this time the name is not main. So what is the name? The name is basically demo5, which I've given the name over here. So this part will not get executed and only the greet function will get executed. So this is how we invoke a module if it contains the main part. So let's see whether it works or not. And there you see you can see that inside module part, it's not working. It's not, getting executed because the main part is different. The main is this time demo 5. It's not the main out here. I believe you understood this. And just one last part I would like to mention out here, that you see, this is not a single underscore, this is double underscore, and this double underscore variables, being prefixed by a double underscore and ending by a double underscore, these are internal variables which are used by Python. So in case you want to make any kind of development in Python, we usually use this kind of variables. There are plenty of such variables which you are going to learn later on in the course. But currently, I believe you understand what I was trying to tell you with respect to creating a module and executing it as a program or executing it as a module. Thank you.